heads up to the inside. The inside is all NASA-grade material, meaning a lot of it's original equipment. So while you guys are inside, we'd ask if you please do not touch anything. Look with your eyes, not with your hands. Don't lean on any of the objects. And keep it as best as possible.
Right.
Is that them? Hello? Are you guys, did you guys purchase the tickets? What did you say? Did you guys purchase tickets for the tour?
Oh, separate purchase?
Yep.
No, we didn't.
Okay. No one likes to eat this. Okay, so the easiest way to get inside is you're going to sit down the hatch like so. You're going to swivel on your butt. And then you're going to crab walk yourself inside. When you get to about here, keep your legs straight. Right above you is a little bar, slide yourself the rest of the way in. The reason why you want to keep your legs straight is because right below it is the emergency activation latch, which will emergency slide. You will knock it, try to look it, and knock it.
Okay. Okay. Oh, inside a space shuttle.
Welcome inside. Now there are 3 decks total to
Do you
the
mind if I
space.
take photos as you talk?
Yeah, go ahead. Now there are three decks total to the space shuttle. The first deck, which is right above us, is the flight deck, and that is where you would fly the space shuttle, control the arm of the space shuttle.
Up there.
Mm-hmm.
Okay.
The mid deck in which you're standing in right now is a living, eating, and work area. And then there's a third deck right below us, which is the storage deck, where you would store most of your materials. Now the mid deck and flight deck is where we're going to do most of our tour from. And this is the 2 areas in which the astronauts will be living in. Now, the mid deck is where you would eat, sleep, work, go to the bathroom. This is everything.
Okay.
You can't go into the airlock because it's actually open to the vacuum of space. So there's no way you can get into
Which
that
is down there.
Mm-hmm.
Okay.
Is this an external airlock or an internal airlock design? Do you know?
External.
Is an external? So they actually have a little bit more space in this mid deck then because of that?
Yeah, because if it was the internal one,
it would actually be right here.
It would be right in here.
Oh wow. Okay.
So during takeoff, you would have 3 astronauts sitting down here, while you would have 4 sitting up top for a crew of 7.
Oh yeah.
If you can imagine a chair right on top of those 4 circles, that would be mission specialist number 3 seating. Number 4 would sit right there. Number 5 would sit right where you're standing.
Yeah. If you wanted to only fly 2 or 3 people, you could take these seats out, though, right? If you only wanted to fly a crew of 2 or 3, you could take these seats out, for instance.
You
Yeah,
need
they're
seats,
not fixed in there. It looks like they're just detachable.
You can actually fly with just a crew of 2.
Yeah.
But you don't want to. You're just flying for a crew of 4 or 7.
Yeah.
Now, once you're in outer space, the chairs are unscrew from the bottom. They fold up like a folding chair, and they get stored in the lower levels, giving you this open space you see before you. And then from there on, you would move on to your mission objectives. Do you mind not?
Oh, I'm too far back. Yeah.
You'd be going on to your mission objectives. If it was research, you'd be coming right over here to these bins right over here. Now, these bins change from mission to mission depending on what is required of them. What you would find right in front of them would be a detailed listing of what was inside each particular container, like this one says what was in this one. Okay. Also, each astronaut gets their own personal container, as you can see from these ones right here. Now, that's very generous when you start to think, when you start to realize that for every pound it takes to bring up into outer space equals to almost about $100,000 worth of taxpayer money. And you've just given 7 astronauts about 2 or 3 pounds worth of
first class
space. So, what you would usually find in those things is probably some astronaut's favorite shirt, clothing, maybe a picture of their family, also some candy if they wanted to bring aboard some candy, also a few other things, electronics, anything else. Now, if you're not going to do anything over here, then you would probably move on to another task, which is the airlock right over here. Now, as you can see, there are 3 sections to the airlock. There's the first, second, and third sections. The second section in the middle is actually the most important, since it has 3 separate duties it has to fulfill. One, it's a storage area for the spacesuits in which you see the astronauts wear when they go out in outer space, those big, huge white ones. Second, it's where you would leave the space shuttle when and if the space shuttle was docked with the International Space Station or any other space station. You would just go in that section and go straight up.
Oh, straight up?
Yeah, straight up.
Not, yeah, okay.
And third, it's where you can control the depressurization and the repressurization of the airlock system itself.
So the door, this is the genuine door?
Yeah.
Okay.
Now, once you,
it's pretty big.
Going out in outer space is not like in the movies where you see somebody can just walk into an airlock, put on a suit, and pressurize and float themselves. It doesn't work like that. At least not for the space shuttle. They have to prepare at least 24 hours in advance before they can actually do that. And the way they do that is they bring down the cabin pressure on all three decks, which is from 14 pounds per square inch to about 10 pounds per square inch. So basically going from like normal sea level to about, I think about 10,000 feet above sea level. Okay? Once that is done, you have at least 20 or so hours to adjust to it. A lot of people can adjust to pressure differences fairly easily. Fast forward to about 2 hours until the mission starts. Those astronauts who are trained to go out in outer space, and there's usually two main trained astronauts, but the third is backup. Okay, and those two will start getting themselves prepared. They're going to take off their clothes. They're going to put on some diapers. They're going to put on a jumpsuit that's going to monitor the heart rate, blood pressure, and so on and so forth. Also, they're going to breathe 100% oxygen. While the third astronaut is going to go inside the airlock and grab those suits and bring them in here so they can put them on in relative ease and comfort. Once they have the suits on, those two astronauts are going to be guided into the middle section by that third astronaut. The third astronaut is going to check their seals, and then it's going to come back out once they are getting their thumbs up. Then the third astronaut is going to grab the airlock, leave the two inside, close it, crank it shut, and lock it. From inside, those two astronauts are going to depressurize even further. They're going to go from 10 psi all the way down to 0. The suits in which they're wearing are pressurized to be 4 to 3 psi, so they're going to have to hover a little bit while their suits are sealed up. Once those suits are sealed and everything is gone, and once those suits are sealed, they're going to drop all the way down to 0. Once they hit 0, they're going to float to the last section in the back, open up the airlock from there, and float themselves right on out. Typical work time for any astronaut is anywhere from 3 to 8 hours.
Tethered? Are they tethered?
Of course.
Right.
Yes. Once they're in outer space, they will start doing their job. They cannot come back in to use the bathroom. They cannot come back in to eat lunch. They make sure they have a big breakfast at the head of time, and they're also wearing those diapers.
In here? Breakfast?
They have breakfast in here.
Right.
Yeah. During that time, those astronauts, they are in a miniature Earth in those suits. It has protection against radiation, it has coolant, it has air, it has water, it has a power source for the cameras and lights and an air system on board. Okay? When they're done working in outer space, they're going to come back inside. They're going to repressurize the airlock. Now that's going to be a lot harder. It's going to be a lot longer than it did to depressurize it, because it's a lot harder to come back up from deep pressure than it is to come back down from.
It's like you could get the bends, for instance. Yeah.
When you come back in here, you're going to take off the suits, get them clean, get them ready to be used at a later date and time, and then store them back in here.
Sorry, just again to recap. You said it's harder coming back into a pressurized.
Yeah. Going from a low pressure back up to a high pressure.
Low pressure is outside.
Yeah, the low pressure. The suits are inside.
Right.
The suits are low pressure, 2 or 3 or 4 pounds. It's like deep sea diving. You know how you go, it's easier to go down.
Deep, so the suit is deep.
Like a deep sea dive, yeah.
When you're in that suit, it's deep pressure.
Yeah,
it's low pressure.
It's low pressure, 3 to 4 pounds per
Oh,
square.
so it's like the opposite of the bends. You're just, because you would be pressurizing too fast.
It's still, you're going back up.
Back in here is back up. Back up to the surface, say
you just don't, because going in here, you can go down faster.
Okay.
But coming back up, it's a danger.
Okay.
Which is, here is back up.
Go in there, in the airlock.
Right.
When you're in the airlock, you're at 10 pounds per square inch, and then you go down. Now it's easier to go down, then you're safe. The suits are pressurized to be 4 or 3 pounds per square inch.
Okay.
Then, when you come back inside, you have to come back up from 0, the airlock. Once they reach 3 or 4 pounds per square inch, they're going to open up their suits to the rest of the pressure inside the airlock, and then they're going to go back up from that low level up to 10 pounds per square inch. Up to 10 psi, and then they're good.
I think something else
but
must. Are they breathing oxygen or are they breathing air?
Breathing oxygen, 100% oxygen.
So they don't necessarily. They couldn't get the bends because they're not breathing in nitrogen.
The nitrogen will be pumped out of it. They'll be breathing it, pre-breathing it ahead of time.
So when do they switch? So the internal environment of the space shuttle is air, right?
Yeah.
But then they're breathing oxygen in their. You say they're breathing pure oxygen in their EVA suits, so they have to switch from air to pure oxygen.
They'll be doing that. They
do that in the pre-breather here in this room
before they actually go in there.
Okay, and in the pre-breather, there's nitrogen in there. Is that what you're saying? Which then can be.
The nitrogen's already in your system. The 100%. Is taking it out.
Right. So
have you done diving before?
Yeah, I'm a diver. So it seems like once you've done your pre-breathing and you're breathing pure oxygen, and now you're in your suit, it doesn't matter. I've not been to this level of diving where I'm breathing pure oxygen, but it seems to me that chance of getting the bends is over because you're not breathing any nitrogen in anymore, and the bends comes from the nitrogen.
Told, they have to do it slowly because they don't want to catch the bends. Is what I've been told, and that's
there must be some other physiological. And also this is why you're confused. The up and down is reversed. In this case, if you're saying it's harder to come back in from space than it is to go out into space.
No, I said it was hard. It's
okay.
Hard to repressurize. Come back up from the low pressure.
Right, so if you're outside in a suit and you're coming back into the ship, then it's harder, is what you're saying.
Yeah, because they have to stay in the airlock a lot longer.
But isn't the pressure in the suit lower than the pressure in the space shuttle?
Yeah.
Yeah, so that's backwards, because that would be like going from the surface at a dive, diving down to like 80 feet.
Yeah.
That's always easier than coming back up. You can dive down, you can pressurize as fast as you want.
Yeah.
As fast as you can possibly dive.
That's what I've been saying.
It's depressurizing.
That's what I've been saying.
Yeah, so I think it should be the other way around. I think it should be on the way out, because you're depressurizing on the way out,
no,
right?
that's what I've been saying. I've been saying, I think you've kind of flipped it around.
Yeah, there's got to be something I'm confused with.
Yeah, you're confused about. I'm saying it's easier to go down in the pressure, is what you meant by diving, right?
Yeah, when you dive,
yeah, you go down in pressure.
You're going down in depth. You're going up in pressure. Pressure is increasing. Yeah, you start at 1 atmosphere, and every 30 meters or so, you increase 1 more atmosphere. So at 100 feet, you're basically breathing 3 or 4. Is it 3? 4 atmospheres of pressure. So when you surface after diving, you're decreasing in pressure. You're going back to the surface. So it's the opposite here. The surface is more like what's outside in space, because that's lower pressure. The interior is higher pressure. So either there's something about the oxygen pre-breathing, which I don't know. Which I don't know about because I've not done that kind of thing. There may be some physiological response about coming out.
I can always recheck.
But yeah, that's actually really interesting. Because I've never heard that.
They had to do it a lot slower when they came back inside.
Yeah. That's interesting. Well, I'll have to figure that out.
So
anyway.
This is the sleeping area for that for the astronauts. These are hammocks that will be stored in the lower levels. When it comes time to go to sleep, you pull them on out and hook them up to any parts inside the area, from the floor to the ceiling to the walls. Right over here is the rehydration station. This is where you would prepare your meals. Now, when they do a dehydrated meal, they stuff it inside the rehydrator, close it, lock it. Inside would be a needle that would punch the package. And then you would dial in the volume or ounces of water, then hit hot or cold to rehydrate the food. Take it back out, put it in the convection oven, heat it up, and then just eat it normally. Lastly, the bathroom, which is right over here.
A door for privacy.
The famous bathroom.
Now, you do have these curtains here for privacy. You got these stirrups for your feet. You got these bars right here to guide you in and lock you down. You have your liquid waste collection. You have your solid waste collection. Liquid waste is rather simple. Basically, what you do is you grab yourself a funnel from here, connect it to here, and they have funnels for both men and women. Connect it, connect yourself to it, turn on the suction, and then just go. It's exactly like peeing into a vacuum cleaner hose while it's turned on, just probably not as strong, and I don't suggest you doing that. When you're done, with the liquid waste, it can be dumped into outer space. It just gets sprayed like a fine mist into outer space. With solid waste, you cannot dump into outer space because it would become a navigational hazard, and you don't be that person who has to explain how you knocked out a GPS satellite with your waste. So, what NASA developed and what you see here is actually one of several generations of bathrooms. The first generation was known as the poo slinger, and basically it was an egg-like device with a blender-like blade that span around, and then they had an intake and then it had an outtake. The intake brought in the waste, shredding the waste, and then flinging it to the walls of the container, and then when you're done, it sucked all the air out through the other hose out into the vacuum of space, freezing the waste to the container's walls. And then you were done. When the mission was complete, you brought it all back, and a company would come in, take it out, clean it, repair it, at the cost of the U.S. taxpayer about $50,000 per space shuttle mission. So they did upgrade it, making it more cost-effective, at the same time making the bathroom more flexible in time-wise, because the old bathroom system would only last for 14 days. Now with the older system, all they had to worry about was how much storage containers they had left downstairs.
What's going on the ceiling? Can you fly the shuttle while you're in there or something? This is there's a lot of controls for a bathroom.
Yeah, the bathroom has a lot of set controls.
It's like a flight.
It's more like to power up. It takes about 30 minutes to power up and get into this whole thing.
30 minutes? Wait, so every time you want to use it, you have to know 30 minutes in advance, or? Not just once per flight. Every time you use it, you have to power it up for 30 minutes before. Wow.
What are these?
These are just holders just to put stuff in so that it doesn't float around, so you don't lose it. You just stuff stuff in here.
Yeah.
Okay. So, any more questions or anything else?
Oh, that's fascinating.
Okay. So, I'm going to show you guys on how to get up to the flight deck. Easiest way to get up to the flight deck is you guys are going to climb up on this ladder right here. Okay. Let me just make sure this is okay. Okay. Climb yourself on up.
Thank you. This part I can touch.
Right here, off to your left is a golden bar attached to the commander chair. Off to the right, in the floor of the flight deck, is a yellow milk jug handhold. Grab onto that. Use those two to pull yourself on up.
Okay.
Get your knees onto the floor of the flight deck. Crawl away from the hatch and stand up carefully because it is a low ceiling.
Well, all right.
Yep.
You made it. Ooh. Oh, what a view. This view you don't get in space camp because they don't have
On my knees, yeah?
Yep.
a payload bay.
And you can use this bar right here to get yourself
And there's
in.
the hatch. Excuse me. Wow, this is the cool part.
So yeah, welcome to the flight deck.
Almost had to remind me not to grab the joystick.
You have...
Where's the There.
This one is the cool one to me, but that's the...
Okay, careful.
Yeah. So, right. That's
That's quite a view, huh? And then this. So, I see that there are latches on these.
Yes.
Do the windows detach?
Yes, and it's for the SkyGenie escape system. Now, there are two ways of getting out of the space shuttle. Both ways only work when the space shuttle is coming back from outer space. There is no other way to get out of the space shuttle during liftoff or during in-flight in outer space. Now, this one works only when you have landed. So if you can imagine, you've landed safely, but you need to get out in a hurry. So what you do is you grab onto that yellow and black handhold right there. You pull it. The outermost glass hatch right above this one will pop off. Using the astronauts, we'll pop these hatches off, and in each one of these bags will be your own personal rope. You grab your rope, tie the rope into here. Using the chair that's still stationed right here, because you did come back from outer space, you're going to climb out the window, tie the rope around your waist, and then rappel down off the side of the space shuttle.
So that is the...
That is one of the two ways of getting out in case of emergency.
So you're saying that's the one where you have to already be on the ground? What about the one where they're doing the parachute thing and they've already come through?
Well, yeah,
is that the same thing?
That would be through the hatch.
Oh, yeah, you go through the hatch.
Yeah,
Okay.
and once they reach a certain altitude in which it's
Yeah,
appropriate for them to
how
bail out,
fast it is,
the commander will keep it as stable as best as possible. He's going to order the astronaut who's closest to the rehydration station to pop the latch. The hatch is going to come off. A mechanical pole is going to extend itself out and below the space shuttle. And then from there on, the astronauts are going to attach their parachutes onto that pole, jump out. The pole will guide them below the space shuttle, and then pull on their parachute as they leave.
Now, I saw some scratches down the side of the trainer. Is that from the training?
Training of the SkyGenie escape system.
This system, the one you described here?
The one I just described.
Yeah, because that one would be next to the hatch. I presume there are scratches there too next to the hatch?
Not as much. Probably on the hatch itself, because I know they did a lot of emergency procedures through that one, but the actual bailing, I think they did do that from a plane.
Yeah. So this is if you're on the ground, you got to get out quickly and...
Yeah. You would use this section.
Huh. People downstairs are in tough shape, I guess. They have to crawl up here.
Yeah.
What are
Okay.
these red knot things
Very
on the
cool.
ground?
They are actually spikes for the chair. They've just been placed there just so that people don't trip over them, because they blend in pretty well with the floor.
So, sorry, these are all switches.
Yes.
So, right, like in the lunar lander.
Yes.
That's, I mean, more or less.
Yes. You can actually tell which ones are the most important ones because they're the ones that have devil protection onto them.
Like which ones? Where?
Like those, like these two. And then the ones forward up front.
Don't press this
No, I'm not.
accidentally.
I'm not preaching anything.
No, I mean this is like this is
why-
telling the
that's why-
commander don't press
Right,
this
I see.
accidentally.
But the lunar landers didn't have they didn't have those, did
Yes,
they?
they did.
Did they?
Yes.
And when they knocked off, when the the Apollo 11, which bit was knocked off?
I don't know. I haven't seen the inside of the Apollo capsules. I wouldn't know which ones
Okay.
they knocked off. I do know that most of those belong to the computer systems on board the space shuttle. And the computer is actually a very low-tech piece of equipment. I mean,
Back in the 60s,
back
60s and early 70s.
literally late 70s, early 80s through the 90s. The computer system, the computer system was basic. I believe it was like it was an Intel something processor. The same ones they would find inside calculators from the 80s and stuff like that. And there was about 5 of them. 4 were made the same, were programmed the same way. Well, a 5th one was programmed completely separate from the 4 to be to act like as a governor, or to act like a check writer, so that if any of the 4 were like breaking or had a problem, and you turn on the 5th one to fix it, it would be able to tell you if the problem was real or not, because the other 4 would be telling you one different thing, and this one would be made in a completely separate way. Would be like that one would be the one you would check the most. So
oh, this is the Canada-Arm stuff, I guess.
the hatch, this front section you see right here is from the 80s all the way down to the late 90s. This is the whole setup from during that time. After that, they did upgrade it to what is now known as a glass cockpit. Basically, they just got rid of most of the gauges and all the other devices you see right here and put them onto several screens. Right in front of the commander pilot would be 2 screens. Commander will also have another 2 screens, and right in between them will be 5 smaller screens. Basically, recycling all the displays and putting them onto these smaller colored screens on which they can see and have a lot. Right over there would be the commander seating, and
Sorry,
right over
where?
here, the commander would sit right here.
Oh, sorry, here, right.
Yes,
I thought you were pointing, yeah.
and then the pilot would sit right here. Now these 2 are typically the military personnel on board the space shuttle, flying countless hours in the U.S. Navy, Air Force, and Marine Corps.
And simulators?
Yep, and simulators. Yep.
Yep. That's an awesome view out there.
Yeah, it really is great.